Okay, let's just be real for a second. The amount of hype around AI it's a lot. It feels like every single day there's a new buzzword, a new promise that sounds way more like marketing than actual engineering. So in this explainer, we're going to cut right through all that noise. This is a no-nonsense, practical guide to what these terms really mean for us. Let's get into it.
Yeah, exactly. And that's what we are not doing today. We are going to blow past the buzz and get right into the mechanics of it. Look, this isn't some magical black box stuff. This is about defining these terms by what they actually do, especially for those of us who live and breathe network operations day in and day out.
So, yeah, that's the big question, right? From our perspective, an engineer's perspective, what are these things? Are they just different words for the same thing? Not really. They actually fit together in a pretty clear hierarchy, and once you see that structure, it all starts to make a whole lot more sense.
All right, so let's start by building out a simple framework. I want you to think of this hierarchy in three parts. You've got the goal, you've got the method you use to get to that goal, and then you have the engine that powers the whole thing. Get this structure down, and everything else is going to click right into place.
Okay, so at the very top, you've got artificial intelligence, or AI. Think of this as the giant umbrella term. It's the big picture goal, right? The whole idea of making a computer think, reason, learn, and solve problems like a human expert would. It's not a specific thing, it's the destination we're trying to reach. So, if AI is the goal, then machine learning, or ML, is the main method we use to get there. Instead of you or me writing a million lines of if-then code for every single possibility, we just feed a system a whole bunch of data and let it figure out the patterns for itself. It's all about learning the rhythm of the data without being told exactly what to look for.
And that brings us to deep learning, or DL. Now, this is the super powerful engine that drives the most advanced ML. When you're dealing with huge, messy, complex data, I'm talking raw packet headers, telemetry, images, you need more firepower. DL uses these things called neural networks in layers to find really subtle patterns that a simpler ML model would just completely miss.
Okay, so we've got the hierarchy down. Great. But so what? What does any of this actually mean for us network engineers on a Tuesday afternoon? Let's translate all this theory into stuff you'd actually see on the job. This is where it gets real. This cheat sheet just nails it. Think of it like this. AI is the expert system that can troubleshoot a tricky Wi-Fi problem, just like a seasoned pro. Machine learning is the system that notices your guest Wi-Fi gets slammed every day at 2 p.m. and automatically adjusts resources. Deep learning, that's your advanced threat hunter, digging through packet headers, and generative AI, well, that's your new best friend for writing an ACL from scratch.
All right, let's really dig into that machine learning example. For years, we've all lived with this, right? Static thresholds. Hey, wake me up if the CPU goes over 80%. The problem is, that alert has zero context. ML gives us dynamic baselining. It actually learns the unique rhythm of your network. It figures out that 80% CPU is totally normal during that weekly backup, but it's a massive red flag at 3 a.m. on a Sunday. It learns what's normal for you.
Okay, but deep learning, that takes things to a whole other level. It's not just looking at one or two metrics. Think of it like the ultimate deep packet inspector. It's capable of sifting through millions of raw packet headers, looking at timing, even analyzing patterns in encrypted traffic to find the faint signal of a brand new zero-day threat. It's finding the stuff that has no signature, stuff that's never been seen before. And then you've got generative AI. This is the one that's got everyone talking, right? Because it doesn't just analyze data, it actually creates new things. For us, that's a total game changer. It becomes your new config assistant. You don't have to go digging through a 2,000-page PDF anymore. You just ask it in plain English, hey, write me an ACL to block TikTok for the finance VLAN, and poof, it generates the config for you to check and deploy. And this quote, this just perfectly nails what we're talking about with these specialized models. It's like having a CCIE in a box. We're talking about AI that has been trained on decades, literally decades, of networking documentation, best practices, and real-world troubleshooting tickets. It's not some generic chatbot. It's the distilled wisdom of an expert. So, what's the big takeaway from all this? The bottom line? All this tech is fundamentally changing IT operations. It's a massive shift away from all that manual toil and toward intelligent automation. There's a name for it, agentic ops. And let's break down what that actually looks like.
Look, let's face it, our environments are just getting insanely complex, and there just aren't enough senior-level people to go around. This is where AI steps in as a massive force multiplier. Your job starts to shift. You're not just the one in the trenches doing everything anymore. You're becoming a supervisor, managing a team of incredibly capable digital teammates that handle all the repetitive, time-consuming stuff.
And this is what that new day-to-day actually looks like. You've got an autonomous agent watching the network 24/7. When it spots an anomaly, it doesn't just send you a useless alert. No, it thinks through the problem, figures out the root cause, and comes up with a step-by-step plan to fix it. And this is the most important part, that plan gets sent to you, the human engineer. You are always in the loop. Nothing happens without your say-so. Once you give it the green light, the agent goes and executes the fix.
And to make all that work, to build something you'd actually trust with your production network, you need some serious domain expertise. This isn't a model scraped from the public internet. We're talking about an AI that's been trained on, get this, over 40 years of Cisco's own networking history, technical docs, and real-world best practices. That's the kind of depth it takes to build an AI you can actually rely on.
All right, so where does this leave us? What does all this mean for our jobs, for our careers going forward? I'll tell you right now, this is not just another trend that's going to fade out in a year. This is a fundamental shift in our industry. It's basically a whole new protocol stack that we all need to start mastering. I want you to really let this next part sink in. Here's the key takeaway of this whole thing. For our entire careers, we focused on mastering things like the OSI model, TCP/IP, BGP. Well, right now, AI is the new protocol stack. Understanding it and knowing how to leverage it is becoming just as fundamental to our jobs as knowing how to configure a routing protocol. The tech is here. It's not coming, it is here. And it is absolutely changing the game. It's changing the nature of what it means to be a network engineer. So the only real question left is, are you ready to learn the new stack?